So this is the last question on workbook activity 01-2, and it's a really good example of unit analysis and why it's important to make sure that you label all of your conversion factors as you go along and have kind of a linear, organized approach for solving the problem. So this problem's looking at how much fluoride we would need to purchase for a city of 50,000 people for a year, assuming that the population each uses 150 gallons per day. So we start out with 50,000 people and we multiply their water usage of 150 gallons per person. So you can see that I've set it up here so that the people part of the unit cancels out algebraically. That gives us 7.5 times 10 to the 6 gallons used daily in this little town. If we look at that, gallons per day, and we see how many days we have in 1 year, then again we can set it up algebraically. We have our 7.5 times 10 to the 6 gallons per day times 365 days in a year, which gives us a total of 2.74 times 10 to the 9th gallons per year. So then the next conversion, we need to get that into liters. So 2.74 gallons per year times 3.79 liters in a gallon allows us to cancel out our gallons and get into liters per year, which is 1.0 times 10 to the 10th liters per year. And then we are going to get that into how many grams of water used per year. And I'll tell you why in just a second. So we take our 1.0 times 10 to the 10 liters per year times 100 milliliters, 1,000 milliliters per liter times 1 gram per milliliter. And that allows us to cancel out all of our units, liters, milliliters, to get to grams per year. 1.0 times 10 to the 13th. And we take that value and we look at if it takes 1.0 times 10 to the 13th grams of water per year, how much fluoride is found in that volume of water. So 1.0 times 10 to the 13th grams of water. And they told us that there was 1.0 parts per million of fluoride, which means for every million grams of water, there's 1 gram of fluoride. You could say the same thing for any million gallons of water, there's a million gallons of fluoride. The unit stays the same. It's just a 1 to 1 million ratio. So in this case, we're going to cancel out our grams of water to get into how many grams of fluoride we need per year. So we've got 1 times 10 to the 0, or 1.0 times 10 to the 13th, and then we divide that by 1 times 10 to the 6th grams of water, which leaves us with 1.0 times 10 to the 7th grams of fluoride needed per year. And if we know that this product that we can buy, sodium fluoride, is a common source of fluoride added to water, they told us that in that compound, sodium fluoride, 45% of the compound is fluoride, so just about half. And so we need to find out how many grams of fluoride would be provided to us, or how many grams of sodium fluoride we would need in order to provide this 1.0 times 10 to the 7th grams needed. So we take that value, 1.0 times 10 to the 7th grams of fluoride, and we multiply that by 100 grams of sodium fluoride contains 45 grams of fluoride to cancel out our grams of fluoride, and that leaves us eventually with 2.2 times 10 to the 7th grams of sodium fluoride needed to be purchased. And the original question asked you to calculate how many kilograms of sodium fluoride you would need, so we just need to convert using this factor right here. So we cancel out our grams. 1 kilogram is equal to 1,000 grams of fluoride, or of anything really. Cancel out our grams and we're left with 2.2 times 10 to the 4th kilograms of sodium fluoride would be needed. So you can see if you go through each one of these slides how important it is that we include units each step of the way, and we always take the time to look at what we know to be true and where we are trying to go. And if you don't include the units as you go along, it's very, very difficult to figure out where you might have left something off, or if you've already done a calculation. It's very hard to track what's been done and what still needs to be done. So this is a really good illustration of why you should always include your units and have things laid out in a very straightforward and organized fashion. So make sure you take a look at this, and if you have any questions, come and ask.